welcome to this, our wonderful and outstandingly exciting lesson on applying function notation. Yes, I know, function notation. Actually, it's incredibly important. So, those of you who are being educated, or at least attending my lessons, that is the work I'd very much like you to do, and it slightly differs from the work guide. Good news! Don't do question 8 or 9. Those of you who are watching from internet land and have nothing better to do on a Friday evening, hey, welcome. Let's make a start. So, let's do a quick recap as we normally do. This chapter is probably so important I can't tell you, right? Those of you who are in Australia and doing methods 1 and 2 and going on to methods 3 and 4, functions and more functions, I cannot tell you how important it is. And again, I will reiterate that when you have a function, if you have f colon, let's do real mapped onto real of a function of x is equal to x squared, this is function notation. For SACs, for exams, for absolutely everything you do, please make sure that you write stuff in function notation. If you have some sort of a restricted domain, something from like these lines, again, function of x is equal to x squared plus 7, for example, this is all incredibly important. And as I say over and over again, reading this function is so important. Remember, this here is my domain. Those are the x values that are possible in my function, or those are the x values I want to go into my function. This is just mumbo jumbo. We write it. Thank you very much. University, you can sort it out for everyone else. And this is my actual function. This is the relation. This is the information that says, well, x and function of x. Also really important to remember that f of x and y are interchangeable. Really important. I'm going to come back onto this in a second. But domain and range are the key to actually doing really well in methods. One last thing I need to say to you here is, with straight line graphs, please remember that if you have a straight line graph, if the domain is not restricted, then your domain will be all real values. There's generally no reason why a straight line graph wouldn't have real values as the domain, which would also suggest that my range is also real values. And if we want to write this officially, x is equal to real, and f of x, is a set of real 2. That's the official way of doing it. Now, when you have something like a parabola, if we actually limit the domain, and I'm going to cut some of this off, and we know, for example, that this value here is -1, and this value here in terms of x is 4, then be very careful when you work out the range. The range, you have to remember, is the highest y value and the lowest y value. And with parabolas, huge trick in exams, that my advice to you is always find the turning point, because that will actually help you find the lowest possible value of your range. Also, as I've said today, and I'll say over and over again, in Australia, this is a CAS course. You can use your calculator. Use it to sketch every single graph you are ever given. It'll take you seconds to do it, but it could save you hours and hours later. Now, one of the most important things to remember with any recap is what this means. And as I've just said, if you look at the idea that f of x is equal to y, then what does f of 1 equals 7 mean? Absolutely, for those of you who are screaming at the screen, that is just another way to actually say a coordinate. What do you notice? Well, there is a 1 where there is an x, and there is a 7 where there is a y. And the only thing that has an x and a y in it that, as far as I'm concerned, at this time on a Friday night I can think of, is a coordinate. So that's just another way of saying 1,7. Why am I telling you this stuff? Because it's actually going to come in useful in about 3 seconds time. Alright, so this lesson is basically, and it says there, a review of the Methods 1 and 2 textbook. If you have no idea what that means, well, then just accept this as sort of understanding of a wider context for functions. This particular session, we're going to look at practical domains and equations of lines given certain coordinates. Now, what is a practical domain? If, for example, look at this function here, v equals 4/3 pi r cubed. Now, if I remember rightly, that is to find the volume of a sphere. Now, we get so used in maths to having equations given in terms of x and y, that it takes something very, very small to trick us to end up with saying, well, actually, this, if we look at our equation, means we're going to put the value of r into my equation, and out is going to come my value of v. So at all points on my function or in my graph, if we were to plot coordinates, we'd actually be plotting r against v. So I'm now going to delete this and say r, and I'm going to change the y to a value of v. So now the values of r are effectively my domain, and the values of v will be my range. Now, don't press stop, not just yet, guys. This is a preview video and you've reached almost the end of it, but it does continue over on mathsguru.com. Mathsguru.com, yep, that's my custom website. Bits of it you can see around me at the moment. That has been designed to allow the videos to be easier searched than they are on YouTube. So you can search by chapter, by textbook. Each video has downloadable notes for you, so you can put them in your summary book or your exercise book. There are exam questions, and there is more and more content and more stuff coming as time allows. So head on over there. It's absolutely free to sign up, and I'm doing everything I can to make sure that you guys enjoy maths and actually take out the mastery of maths. It is not as hard as you think. It is all smoke and mirrors. Okay, thanks very much. Take care, guys. I look forward to seeing you in another video. Stay safe.